Hello and welcome to Spark Math. I'm teacher Alex and today you're about to discover the excitement of learning math with us. This is a recording of one of our classes showcasing our unique approach to learning that combines live teaching with our award-winning interactive and gamified platform. At Spark Math, we believe in making math not just understandable, but genuinely fun and engaging for kids ages 5 to 12. If you enjoy this class, you can book a free 30-minute trial class using the link in the description. So are you ready to join one of our math classes? Let's dive in and experience the joy of learning together.
All right, so moving on with our remainder problems to the next part. Remember what we were talking about with remainders is the remainder kind of tells us where we're at in the pattern. Okay, remember that if we have a remainder of 0, that means we're on the last number or item or term in the pattern and things like that. So let's take a look at our first example. And it looks like we have a quick game to play here. Okay, so your game rules are this. The toy moles are lined up consecutively. So as you see here, we have moles 1 through 16. Okay, it says start hitting from the first mole. And what you're going to do is you're going to hit 3 moles into the holes and then leave 1 on the ground. Okay, so you're going to start at the first mole. You're going to hit the first 3, and then you're going to leave the next one standing. Then you're going to hit the next 3, then you're going to leave that next one standing. And what you want to figure out here is the question at the bottom is there are how many moles left on the ground.
Pattern.
Okay, so if we're thinking about how we want to do this here, okay, we're going to start by hitting the first 3 moles. And then we're going to leave the next one standing. Then we're going to hit the next 3 moles. Then the next one's going to be standing. Then we're going to hit the next 3 moles. The next one standing. Then we're going to hit the next 3 moles. And then we have that last one that's going to be standing. So who feels like they know how many moles we have left standing up? Queena, how many do we have left?
Well done.
Good job, Queena. Yeah, so we have 4 that are going to be kind of left over. So we're going to be using this little whack-a-mole situation to figure out our first question here. So our first question is this. 72 toy moles were arranged in a row in order below. Benny played whack-a-mole and hit the toy moles consecutively from the first one to the last one. Okay, so we have a bunch of moles here. Okay, following the pattern of hitting 3 into the holes and then leaving 1 on the ground. After Benny finished the game, how many moles were left on the ground? Okay, so again, to start with, okay, how many moles do we have total? Vivian, how many moles does the question tell us that we have? Yes, we have 72 moles.
72.
Okay, and then what was the pattern of how we were hitting the moles? Oh, it looked like Queena. Yeah, it says that she isn't. Yeah, something's not going on there. Okay, but anyways, the way that Benny hit the moles was we hit 3 into the holes and then we left 1 on the ground. So we hit the first 3, left the 1 on the ground. Hit the next 3, left 1 on the ground. Hit the next 3, left 1 on the ground. So on and so on and so on. So our pattern, we would hit those 3 moles and then we would leave 1 standing. Okay, so if we want to kind of solve our question here, okay, what we want to do is we want to kind of think about each of these as groups. Okay, so we have all of these different groups. In a group, we have 3 holes in 1 mole. So total, we have 4 objects in each of those groups. So this is going to be very similar to how we were solving the last question. If we're trying to figure out, or if we know how many total moles that we have, what we're going to do is we can just take that and we can kind of divide it into groups. Okay, so what I mean is, remember, each one of these groups were 3 holes in 1 mole, and we have all of these different groups. So if I want to figure out how many groups I have, I know I want to figure out 72 total moles. I'm going to divide that by 4, which is going to give me 18 groups. Okay, so I have 18 groups of these, of the wholes plus the moles. So if I do 72 divided by 4, I'm going to get 18. Okay, 𝗁𝗏, in our groups, how many moles are standing up in each one of our groups? Yeah, 1. So if we have 18 groups and we have 1 mole in each one of our group, we can just do 18 times 1, which gives us that final answer of 18.
Well done.
Okay, so just to kind of double check our problem here, okay, if we kind of worked our way backwards and kind of multiplied out through, okay, if we had 72 groups of 4, we could take 18, multiply it by 4, which would give us 72 total moles. And we know that if we're whacking 3 of them and then 1 of them standing up, we have 1 mole standing per each one of those groups. Okay, so just to review what we talked about here, we want to identify the hitting pattern of the toy moles in the game. So if we had all of our moles here, Vivian, do you remember what our pattern was when we were whacking the moles?
Whack 3, 1 stand. Whack
Absolutely, yeah.
8,
So we're whacking 3 of them,
stand.
we're leaving 1. We're whacking 3 more, and then we're leaving 1. Okay, so our pattern looked like this. So then if we wanted to figure out kind of how many are in a group, okay, 4 terms make up a group. 3 holes, 1 mole. That's kind of what gets repeated over and over and over again. Okay, so if there's 4 total in the group, we knew that we were trying to find what 72 would be, so we can take 72, we can divide it by 4 and get 18 for our final answer there. Okay, we multiplied it by 1 because we had 1 mole in each one of those groups. So let's see if you guys can try some of these. Okay, I'm going to put you guys in practice mode. Click on the game button and see if you can follow the instructions. And now you guys get a chance to whack some of the moles.
Well done.
Vivian, can you try this one here?
Oh, okay. 1, 2, 3, 4, 5. Bam. Well done.
Good job, Vivian. All right, good job with those. Okay, so just for a little extension and transfer here, what we can look at as well is if we have, okay, we can have these different types of patterns where we were hitting 3 and leaving 1. So remember, if we were hitting 3 and leaving 1, that group would consist of 4. Okay, if we were hitting 3 and leaving 2, then that group would consist of 5. So remember, the number that is in the group is important because that's what we're dividing by in our problems. Okay, so if we lined them all up in a circle, okay, it might change a couple things where we're whacking every other one or things like that. So just different types of these whack-a-mole problems that we can kind of look at here. So you guys did a great job with those. Let's look at our next example. So the figure below shows a chessboard with 6 small circles with a chess piece on circle 1, as you see right here. Okay, Abby moves the chess piece clockwise 1 space at a time. After moving 45 times, which circle will the chess piece be on? Okay, so looking at the diagram here, okay, we want to figure out after we move it 45 times, which circle will the chess piece be on? Okay, does anybody have any ideas on maybe how we could do this, what we could do? Vivian.
So we take 45 and then 1.
Yes, Vivian,
And
you are
divide by
absolutely
6,
correct.
maybe?
Good. Vivian, we're going to get there in a second, but you are absolutely correct. Great job. Queen, I see your hand. What are you going to say? Okay, Queen, hold on. I want to go over the question first to make sure everybody knows. Okay, Vivian or Queena, great job, by the way. But I just want to talk about the question and then I'll come back to you for the solution, okay? So for our picture, okay, for our chessboard, remember, we're starting on piece 1 and we're kind of moving this piece one space at a time. So as you see, it's kind of creating a pattern for us. Okay, so as I move this around and around and around and around, okay, if you look at the pattern here, it goes 2, 3, 4, 5, 6, 1. Okay, so after we moved the first time, we end up on space 2. After we move the second time, we end up on space 3, and so on over and over and over again. Okay, so we have that repeated group again. Okay, so that repeated group is important for us because we know that it now has 6 numbers in it. Okay, so just like Vivian said, okay, if we know that we have 6 kind of numbers or terms that are in that pattern and we're trying to find the 45th term, we can take 45 and we can divide it by 6. Okay, if we divide 45 by 6, we're going to get 7 with a remainder of 3. Okay, so we've been talking about remainders all class here for the most part. Remember, if we have a remainder of 3, that means that we are going to end up on the 3rd term in our sequence. Okay, so in our problem here, if we have a remainder of 3, this is the 3rd term. Okay, it says right here, it's the 3rd. So we are going to end up, okay, Queena, now's your time to shine. What number are we going to end up on? Okay. Okay. Yeah. Go ahead, Queena. What else were you going to say? Okay, so Queena, you bring up a great point there. So Queena says that she just kind of counted all the way around and around. So remember, the point of our lesson here, or really the point of math kind of in general, is we can use math to kind of make things easier for us. Okay, so instead of counting 45 times, you could just do a simple division problem, 45 divided by 6, and come up with the same answer. Okay, so again, is it possible for you to count and figure out the answer? Absolutely. But remember, we're kind of doing these problems so I can show you guys a way that we can kind of figure out what number we are going to end up on. Okay, so for example, Queena, here's where that method might get you in a little bit of trouble. Let's say I asked you after the 1,352nd move, what piece are we going to be on? Queena, are you going to want to count 1,352 times? No, absolutely not. We're going to be here all night. Nobody's going to get to sleep. Okay, so what we need to do here is instead of counting 1,352 times, we could just divide that number by 6, and then whatever the remainder is what the answer is. We want to use the remainder the best we can to kind of help us solve these problems a little bit easier. Okay, so just to kind of double check our answer here, okay, if we have all of these groups, remember 2, 3, 4, 5, 6, 1 was kind of that repeated group, and we have 7 of these groups. Okay, so we can kind of go back and check, okay, 7 times 6 would give us 42, and then we had that remainder of 3, so if we add the 3 to the 40 or to the 42, we are going to end up at 45 there. All right, so just to review this, okay? So again, if we are trying to identify the movement pattern of these chess pieces, okay, remember those chess pieces are kind of creating a pattern amongst itself, okay? So Queena, we just talked about this. Why is it important that we use our remainder to find these problems instead of counting? Yeah, so exactly, Queena. So remember, we're kind of using this method so we don't have to necessarily count. Now, for example, if this question asked you after the chess piece moved 2 times, what piece was it going to be on? Then counting would probably make the most sense. We could just count 2 spots over. But where counting wouldn't make sense is like I asked you, what is if the chess piece moved 1 million times? Okay, you are not going to count to 1 million around the circle over and over and over and over again. Okay, so remember, we want to use this, and we want to use those remainders to our advantage, so we don't have to count all of those times. Okay. Okay, so in our question here, remember we had that repeated group. There were 6 terms that were in a group. So remember the number of terms or objects or whatever is in our repeated group is what we divide by. So we got the remainder of 3. So remember, once we got that remainder of 3, that means that we were on the 3rd number in the pattern, which was going to be the number 4. Okay, so let's have you guys practice a couple of these. Okay, again, it is possible for you to count to figure out the answer, but remember, we want to use that division so we can find the remainder to make our question a little bit easier. See what you guys can do on this.
Try again.
Okay, so Vivian, if we have a remainder of 4, that is correct. So we need to look at our pattern that we made up here. What number is the 4th term? Yeah, remember. Yeah, so remember, the number 4, the remainder isn't the answer. It tells us what number in the pattern we're on. Good job. Good job, Vivian. All right, you guys are all kind of on the challenge problem here. I'm going to give you a minute or two, see if you can think about this.
Try again.
Okay, Vivian, aren't there only 6 numbers in our pattern? So we should divide by 6.
Oh.
All right, great job again, everybody, with those. All right, a little extension and transfer with these here. So a couple things that were important about these chess problems is the clockwise movement. So if we were starting on the top and working clockwise, we would go in that way. Okay, there's also anti-clockwise, or what you might have heard of before as counterclockwise. So that would just be moving the opposite direction. Okay, so again, if we're moving one space at a time, we would create a pattern, 2, 3, 4, 5, 6, 1. Now we might look at some problems that we're moving 2 spaces at a time. So we go from 1 to 3 to 5, back to 1, so on and so on. Okay, so we looked at problems that given the starting number, find the finishing number. We might be given the opposite, where we're given the finishing number, and then we want to work back and kind of find the starting number. Okay, so great job with those. We're going to look at our last example we're going to talk about today. Okay, and we are going to use our hand for this one. Okay, so it says how to count. You're going to raise your left hand, okay, and your palm is going to be facing you. And what we're going to do is we're going to start counting from the thumb on the left of your hand to the little finger and back. So thumb, index finger, middle finger, ring finger, little finger, ring finger, middle finger, index finger, then back to our thumb. Okay, so, and then we're going to go back, index finger, middle finger, ring finger, little finger, so on and so on and so on and so on. Okay, back and forth, back and forth. Okay, so now we've created this pattern here, okay, from the thumb to your index to the middle and then all the way back. Okay, so if we want to count our adjacent fingers one at a time, when you count 10 times, what finger are we going to be at? Well, if you look at the pattern we created, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it looks like we are going to end up on our index finger. Okay, so that's what the kind of problem we're going to look at real quick. Okay. So the first question we were going to look at, following the pattern. Okay, so same pattern we just talked about. We're going to start at our thumb, index finger, middle finger, ring finger, little finger, and then back the way through, okay, over and over and over again. Okay, so as we kind of work our way forward to backwards, so on and so on, we're going to kind of create this pattern again. Okay, we want to know which finger we are going to be at when we count to 50. Okay, so again, another example of we don't want to waste all our time counting 50 times on our fingers. We're going to be able to do our division problem like we've been doing. Okay, so if we want to figure out, okay, what finger will you be at when you count to 50? Remember, our pattern was this. Okay, so our pattern went back and forth, back and forth, back and forth. Okay, so if you're looking at the pattern, the repeated part is your thumb back to your index finger. Okay, then that starts again. So the thumb, index finger, middle finger, ring finger, little finger, ring finger, middle finger, index finger, thumb is going to be the pattern. Okay, so in this counting pattern, the repeated group is going to be 8 numbers. Okay, so if it's going to, and I'm trying to find the 50th, we're going to do the same thing we've been doing. We're going to take 50, we're going to divide it by 8. Okay, when we do that, we're going to get 6 with a remainder of 2. Okay, so if we have the remainder of 2, what finger are we going to end on? Okay, Vivian, what finger are we going to end on if our remainder is 2? Absolutely, good. Go ahead and select the index finger in the answer down there for us. Oh, not the thumb. The index finger. Good.
Wonderful.
Okay, so remember, in that pattern, we had a remainder of 2. And the remainder of 2 tells us we are at the second finger in our pattern, which was our index finger. Okay, good job with that. Okay, so just to kind of review that before I have you guys try some. Okay, so if we want to identify that pattern, remember, we used the counting pattern to create our problem. We figured out what the repeated group was, which was 8 total fingers, the thumb back to the index finger, and then we just divided. Okay, we divided that number by 8 because there were 8 total in the group. We got 6 groups with a remainder of 2. And remember, the remainder of 2 means we were at the second finger in our pattern, which was our index finger. So let's see if you guys can try one here. Go about the pattern, see what you can do.
try that again.
Okay, so Vivian, if we're on 5, remember, the remainder tells us where we're at. So if we don't have a remainder, what's the last term in our pattern? Okay, so Vivian, remember, if we divided by 8, you're telling me that there's 8 fingers in your pattern. So look at what the 8th finger is.
Wonderful! Thank you! Wonderful! Thank you!
Okay, you guys did a really good job with the finger problem there. Great job. Let's go ahead and sum up what we talked about here today. All right, so 𝗁𝗵𝗶𝗶𝗀, what was kind of the big idea with these remainder problems today? What did the remainder tell us? Yeah, it tells us what was left, but 𝗁𝗵𝗶𝗀, when we were talking about our patterns, what did the remainder tell us about the pattern? Yeah, so if we, good 𝗁𝗶𝗶𝗀. So if we have a remainder of 0, that means that we would be on the last term. So remember, our remainder kind of told us where we were at in the pattern. Thank you for sharing, 𝗁𝗶𝗶𝗀. Okay, so we were identifying the pattern in the remainder. So remember, we did our whack-a-mole problems. We did our chess piece problem. What we wanted to do with those is we wanted to figure out how many numbers were in the group, figure out how many groups we are, figure out what our remainder was, and then remember, the remainder told us where we were at in our pattern. Okay, you guys all did a great job with that. Let's go ahead and finish up today. You guys can go ahead and play the jackpot. All right, everybody. Great job today.
That's a wrap on today's Spark Math class. I'm Teacher Alex, and I hope you enjoyed this sneak peek into our exciting approach to math. Our lessons are designed to make math not just understandable, but genuinely fun for kids ages 5 to 12. Interested in more? Sign up for a free 30-minute trial class through the link in the description and join us for more math adventures. We'd love to hear from you, so please drop a comment below with your thoughts or topics you'd like to see. And if you found today's class helpful, give us a like, share this video, and don't forget to subscribe. Thanks for watching, and we look forward to welcoming you to more interactive gamified learning. See you next time!